So I haven't started with the HTTP request here, but basically what we do is there's a controller, it calls out to a service. And in that service, what we do is replicate what the old contract of data was. So for this case, it means fetching an asset, which for us is like a video, and then all of the comments associated with that asset as well. So what we did is we wrote this really simple little request library thing here that you can basically, it executes those in parallel and then joins them all together, and then we can take that data and do something with it. And for us, what we do with it is actually encode it from a new type to the old type. So we're going from a new database schema to an old database schema. And I'm a huge fan of protocols in Elixir to do things like this. It's a really good way to just get these kind of polymorphic, generic kind of things inside of your code base. So in our case here, we call an asset a file reference in the old world. And what we're doing is basically moving a bunch of attributes around and then casting it as that struct for the old world, which we call a file reference. So you can imagine the input here being a new video or a new asset, and then the output is an old file reference. And then what we have to do is basically serialize everything. So we made this really janky little type encoder thing that takes in a type, basically turns everything into a string, and I just did this to troll CTO, sorry. But we take everything as a string, all the inputs, and then turn it into a string and serialize those back out to the clients. And those clients are none the wiser. They think they're still interacting with that old system. Okay, so the next thing I wanted to walk through is a hotly debated subject. And again, I think Andrew did a really great job of speaking at length about how to structure umbrella apps well. I'm thinking about context and breaking things down. So we use the single monorepo, which I think a monorepo has been very effective for our team size. Everyone can contribute to this one single source of code. There's 11 apps inside of it, which is probably pushing it at this point. We're probably going to start to think about breaking those out at some point soon. But for now, it's been great. It means we're all working in one place. All of our deployments are kind of quite simple. Every time we push, we can deploy off of all of this. So the apps look like this. On the left-hand side, we have 4 Phoenix apps. So we have our API, the support tool, Munja, which is the intermediary API, and then this auth app. And then we have a bunch of business logic, and then a bunch of shared components. So the shared components on the right here are kind of interesting. Really, these could be extracted into private hex organization repo-y things now that exists, but we've kept them inside of our umbrella application for the time being. But we have stuff like everything that we do with statsd, we want to share across all the services. We don't want to have to rewrite that every time in all the configuration. So we just dump that in a little app and import that. Similarly, middleware, so we do we have to have like a lot of secure headers. Security is a big concern of ours, working in the video space with large clients. So we put all of those kind of shared components in this middleware library. And then the DB is basically configuration and access into the database with some shared kind of types as well, things like that we need to make use of elsewhere. So just highlighting a few of these applications. So all of the 5 here that I've highlighted are actually things that we deploy and run. So these are apps that aren't just shared code, they're actually things that we look at, run, and people can make requests to and things like that. So all of those applications are built and deployed as separate Docker containers. We use Circle CI 2.0 extensively to do all of this via Distillery. If you're not familiar with Circle CI 2.0, definitely have a look if you're doing Docker-based workloads. What we've been able to do is basically parallelize all of our builds. So every single build there of all of those applications, each one, it will be the slowest build is the one that will take longest. So for us, that's they all take about 5 minutes to run. We do things like green deploys via ECS. You kind of just get all of this stuff out of the box with ECS, which is the Elastic Container Service. I should have said that earlier. And everything we do now is auto-scaled, and we use CPU and memory threshold alarms to do that. Works really well. We basically set it and forget it, and we can see some nice graphs about where we've auto-scaled and how we've met the traffic demands as well. The other part of the app I wanted to walk through was the core application. So for us, core is, as it might sound, it's all of the core business logic. So it's everything to do with services, everything to do with persistence, access policies, lots of deferred logic, everything like that. And what we've done is separated it out into two contexts. One for accounts, so everything to do with managing teams and users and things like that on the platform, and everything to do with projects, which is everything to do with like assets and adding people as collaborators and things like that. We have lots of different collaboration concepts in the application. And effectively, we make use of the core business logic layer inside of the API and the support tool